Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. In this lesson, we're going to learn about solving equations that have variables with powers in them. So to do this, we'll have to, well, it's like solving a normal equation, but then that will generate a radical that you need to be able to simplify. So we're going to go over simplifying radicals as well. All right, so here's a simple equation that has a variable that's raised to a power. So I'm going to handle that just like any other equation, and I'm going to think about, here's my equal sign. There are no like terms to be combined. There's nothing to distribute, so I'm going to head right into isolating my variable, which means use opposite operation. So 5x squared, that term, I want to get the other term away from it, so I'm going to subtract 3 from both sides of this equation. And that's going to leave me with a 5x squared. This becomes 0, and that equals 20. Okay, look back here. I've got 5 multiplied by x squared, so that is multiply. The opposite of multiply is to divide. I need to divide this by 5. Both sides, 5 over 5 cancels out to become 1, and that gives me x squared equals 20 divided by 5. Now, how do I solve for x if I've got x squared equals 4? So that means a number times itself. What number times itself equals 4? You might just know that 2 times 2 is 4. And this is where we're going to practice solving radicals, because some of them aren't so opposite. So what we want to keep in mind is that a number squared, when I take the square root of that, I'm just going to get this value here, right? If I take 2 squared and take the square root of that, well, 2 squared is 4. 2 times 2 is 4, so the square root of 2 squared would be 2. Let's do another one. The square root of 3 squared. 3 times 3 is 9. That's the same thing as the square root of 9. And so the square root of 9 would be 3 times 3. We'll factor this, 3 times 3. So the square root of something squared is always just the thing that was squared. Okay. In this case, I'm going to say the square root of x squared. Okay, well that's going to be x is equal to the square root of 4. I'm going to take the square root of both sides. And then there's actually 2 options, right? Because I could say, well, 2 times 2 is 4. So the root of this, the squared root, right? It's been squared. 2 squared, the root of the thing that's squared is 2. So the square root of 4 is 2. But let's take another example. What about negative 2 times negative 2? Negative 2 times negative 2 would also equal a positive 4. So whenever you take a square root, you actually have 2 cases. You have the positive case and the negative case. And that would be your final answer. Now, there's a lot of situations where we're trying to calculate a distance, especially in geometry. And so by application, if the question was how far or what's the distance or length, then we don't have, those wouldn't be represented by a negative number, so you just wouldn't use the negative version of it. You would use only the positive version. All right, so let's keep going. You need to know all your perfect squares, because when I'm trying to find out the square root of something, if I find it's a perfect square, the root is the number. So I know 1 squared is 1, 2 squared is 4, 3 squared is 9. So for example, 4 squared is 16. So I know the square root of 16 is a perfect square, so its root would be 4, right? 25 is 5 squared, so if I'm trying to take the square root of 25, I know that the root of the thing that is squared is 5. Okay, so you want to memorize these. If you don't know them already, it's just really part of your multiplication tables, right? And past 12, I would say, then you can start using your calculator. But these, you just want to recognize them quickly. So as you're working, it's easier to identify that you have a perfect square. Because in this next example, not everything is going to be a perfect square, and we need to know how to handle that. All right, so here, if I have a radical that I want to simplify, all right, I'm going to start with looking at what basically going to factor this thing and find out its roots. Well, 64, again, knowing my perfect squares, I know that this is going to be 8 times 8 is equal to 64. And as soon as I get two things, in other words, something squared, then I know the root of that, the square root of that is going to be this. So this answer would be 8. But look at this one. This one is not a perfect square. So I'm going to start factoring it. And I'm going to think of, now here's where you kind of need to know your multiplication tables. I'm going to have to think, well, what multiplies to make 27? And off the top of my head, I'm going to say, well, I know that 9 times 3 makes 27. And now I'm going to stop here. 9 I'm going to recognize to be one of my perfect squares, right? So a perfect square can always be simplified outside of the radical. We can take that even further and say that's 3 times 3, right? 3 squared, the root of that is 3. So whenever I find a perfect square, or if I keep going and I get 3 times 3, that can come on the outside of the radical sign. So I'm going to write a 3 out here. What never gets matched up with anything has to stay inside the radical, because it doesn't have it's not a perfect square. So to simplify this square root of 27, this would be the simplified version of that. 3 times the square root of 3, or 3 radical 3. The terminology could go either way. All right. We also, well, I kind of talked about the positive and negative cases, but we'll do a little more practice here. So let's take square root of 50. Off the top of my head, I might say, well, that could be 25 times 10. You might also think, oh, well, that's 25. I said 25, 5 times 10. And this is, or it could be 25 times 2. Either one that you might come up with. I'm going to keep going. Okay, this is 5 times 2. So far, I don't have any perfect squares. Here, this is a perfect square. So 25, square root of that is 5. So 5 comes outside. 2 never matched up, so it stays inside. But if I'd gone this route, I come down here and I say, well, I came down to 5 times 5 times 2. Even if if you didn't initially find the perfect square, when you get all the factors, you'll just match up the pairs. So 5 times 5 is 25, square root of 25 is 5. So 5 comes out, pairs come out. Things that didn't get paired up stay inside. And once again, there is always your positive and your negative case. So depending on your application, you may need to use the positive case, you may need to use the negative, or represent both. Here's another example. Square root of 12. 4 times 3 is 12. I know that. You could have also thought, oh, well, that's 6 times 2. Let's see which way it goes. I know 4 is a perfect square. That's 2 times 2. So the 2's are going to come out. The square root of 2 squared, the square root of 2 squared would be just 2. And then there's a 3 that did not have a partner. It's all by itself. Okay, pairs come out, singles stay inside. And then here, 6 is 3 times 2. All right, so I didn't find it initially, but when I did all my factors, I got a pair. So 2 came out, 3 stayed in. And in both of these, you have a positive case and a negative case. All right, that's it. We'll see you in class.